I'm going to take a look at 3 more questions from maximum and minimum optimization questions. These are all from page 3. So here's question number 11. And number 11 gives you a parabola basically in the form y equals 1/2 x squared, although I rearranged it from the question. And so there's the parabola, and it gives you a point over here at -4 and 1. And it says, where's the minimum distance between this point and the parabola? Where will that line be the shortest? So you can imagine drawing it to another location, someplace up here, and it would be longer than this one. The question is, where does this point occur? So I've labeled this point as x comma y, where y equals 1/2 x squared. And we're going to use our length of a line segment formula, or our distance formula, that looks like this. Square root x2 minus x1 all squared plus y2 minus y1 all squared. So using these 2 points, I get the distance or length formula to be the square root of x minus a -4 all squared plus 1/2 x squared minus 1 all squared. That's the function that I'm going to take the derivative of. I'm going to try to simplify it as much as I can beforehand, however. So d equals the square root of x plus 4 all squared plus 1/2 x squared minus 1 all squared, x squared plus 8x plus 16 plus 1/4 x to the 4th minus 1 x squared plus 1. So I sang my little song in my head to square this binomial and square this binomial. Now I'm going to rewrite it. X squared minus x squared cancels, so I've got 1/4 x to the 4th plus 8x plus 16, plus 17 all to the 1/2. And that's what I'm going to take the derivative of. So d prime equals 1/2, this whole expression to the minus 1/2 times x cubed plus 8. So d prime equals, as a fraction, x cubed plus 8 in the numerator over 2, that's where that comes from, 1/4 x to the 4th plus 8x plus 17 to the positive 1/2. Well, when you set a derivative equal to 0, we're only interested in the numerator equaling 0. So it's only this part right here that we need to set equal to 0. This would produce asymptotes and changes from the left side of the asymptote to the right, but we're not concerned with that because we're not graphing it. So the question just becomes, when does x cubed plus 8 equal 0? When x cubed equals -8, when x equals the cube root of -8, when x equals -2. So if x is equal to -2, y is equal to 1/2 x squared. Y would be equal to 1/2 of -2 squared. Y would equal positive 2. So the ordered pair is -2 with positive 2. That point on the parabola right here is the closest point to -4 and 1 on this parabola. The next question I wanted to take a look at was number 13. Number 13 is a piece of wire that's 40 centimeters long, and you're going to break it someplace, cut it someplace so that with one portion of it you're going to make a circle, and with the other portion of it you're going to make a square. So this original piece, 40 centimeters long, cut it someplace, not necessarily in the middle, so that one piece will make a circle and the second piece will make a square. So we're going to take this piece right here and we're going to bend it into a circle from here to here. We've called it x. So the formula for circumference of a circle is 2 pi r. and that has to equal x. So r equals x over 2 pi. So that's a known relationship we have for that. For the square, the perimeter of a square could be something like this, 4L, and 4L equals 40 minus x. The perimeter of this square has to be equal to this piece of wire. So L equals 40 minus x over 4. L equals 40 divided by 4 is 10 minus 1/4 x. So now we have both expressions in terms of x. So the formula for area of a circle is pi r squared. The area of a square is L squared. So our formula is going to be A equals pi times x over 2 pi all squared plus 10 minus 1/4 x all squared. So let's simplify that before we take the derivative. A equals 1 over 4 pi x squared plus 100 minus half of that would be 5 over 2x plus 1/16 x squared. 10 over 4, half of that. I think I've done this part wrong here. Multiply them together, minus 10 over 4, and double. Having a malfunction here. Minus 10 over 4, multiply them together and double. Gives you minus 20 over 4. That's just minus 5, I think. Now I'm nervous. Okay, let's take the derivative of that and see where it takes us. A prime equals 2 over 4 pi x minus 5 plus 1/8 x. We want to set that equal to 0. So when does A prime equal to 0? When 2 over 4 pi minus 5 plus 1 over 8, equals 0. So 2 over 4 pi x minus 5 plus 1 over 8 x equals 0. I'm going to multiply everything by 8 pi. That way I can eliminate this denominator with this, and I can eliminate this with this. So I'm left with 4x minus 40 pi plus pi x equals 0. 4x plus pi x equals 40 pi, common factor out in x, so x equals 40 pi over 4 plus pi. That's how long this piece of wire is. If you were to find this as a decimal number and subtract it from 40, that would be the length of that wire there. So where do you cut the wire? You cut the wire so that x is that many centimeters long. The last question that I wanted to look at was number 16, where it's a Norman window. A Norman window has a semicircle on top of a rectangle, and they've identified the width of the rectangle to be 2x, so that the radius of the circle could just be x. And they tell us that the perimeter for this one is 8 meters. So I'm going to add up all the outside edges to this to represent my perimeter. So I'm going to have a 2x right here, and then I'm going to have 2 y's, and then I'm going to have the circumference of half of a circle. So the circumference for a whole circle would be 2 pi r, or 2 pi x in this case, but I need to divide that by 2 because it's half of a circle, and that has to equal 8. This was supposed to be 2y, not 2 pi. There's a y and there's a y. So now we're going to solve this for y. So 2y equals 8 minus 2x minus 2 pi x over 2. So 2y equals 8 minus 2x minus pi x. And then divide by 2 and you get y equals 8 minus 2x minus pi x all over 2. Y equals 4 minus x minus pi over 2x. So that was the known relationship, a given perimeter of the window, and now we have the two variables x and y in terms of x. Now what we need to do is take and find the area of the window, and the formula for area is going to be length times width of the rectangle plus 1/2 pi r squared for the circle. Well, 2x times y are the dimensions of the rectangle, plus 1/2 pi x squared is the dimension of the area of the semicircle. So we're going to substitute in 4 minus x minus pi over 2x in place of y. So we've substituted that right there, plus 1/2 pi x squared. So A, the area of the window, is equal to 8x minus 2x squared minus pi x squared plus 1/2 pi x squared. So we can take the derivative of that now. A prime equals 8 minus 4x minus 2 pi x plus pi x. So A prime equals 8 minus 4x minus pi x. That's the simplified derivative. I just added these two like terms. I could have done it earlier actually, but I didn't. So when does A prime equal 0? When 8 minus 4x minus pi x equals 0. When, let's just leave the 8 on this side. Transpose those two terms to the right. So 8 equals x times 4 plus pi. So 8 over 4 plus pi equals x. Now that represents x, which is half of the width of the window. 2x is the width of the window. So 2x equals 2 times 8 over 4 plus pi. So 2x, the width of the window, is 16 over 4 plus pi meters. And that's the width of the window. Hope those help. We'll talk to you later.